Good morning, students. Today we will begin with our first lesson on statistics. This is going to be about 45 minutes lesson. Let me share my screen so we can start with the first slide. Okay. Well, what is statistics? That should be the first question that actually you can ask yourself before you see this video. But usually people think that statistics is just numbers, but really it includes numbers, of course, but the issue is what you can do with the numbers. So the objective is to learn for our lessons is to learn some basic statistics and their applications, and of course to prepare you for later on, especially applications in project-based and project activities. So what is statistics? Statistics is the universal language of the science. Why? Because in all sciences, we can use statistics to analyze data, to interpret data, etc. Careful use of statistics methods enable us to accurately describe the findings of scientific research. We will see some examples in the lesson to follow. Make decisions, make estimations. Statistics involves, of course, numbers, but also subjects and the use of these numbers and subjects. The field of statistics can be roughly subdivided into two major areas: the descriptive statistics and the inferential statistics. Before we finish today, I have a nice short video to show you for presenting or actually summarizing whatever I tell you here today, more or less. So descriptive statistics is what most people think of when they hear the word statistics. It includes, of course, the collection, presentation, and description of numerical data. And the term inferential statistics refers to the technique of interpreting the values resulting from the descriptive techniques and then using them to make decisions. So we have the descriptive statistics to collect and to organize our data. The method of collecting is another story, and we will discuss a little bit about that also, the selection of samples, etc. But the most serious part of the statistics, of course, is how you take your data, use your data to analyze and make decisions using them. So let me go to the next slide. Let me stop sharing, make sure it's recording. Okay, recording. Statistics is more than just number, as we said. It is what is done. So one of the definitions you can find, of course, you can find different definitions from in different books, is the science of collecting, classifying, presenting, and interpreting numerical data. Okay. So remember this definition. If anyone asks you what is statistics since you started this course, what are the uses of statistics in general speaking? In education, descriptive statistics are frequently used to describe test results, for example. So when we have a test, you will have a score, we will have an average of this score, maybe we'll have a ranking, who will receive the highest and who is at the lower bottom, who passed the average, how many, what percentage are above average, etc. So your test results is a collection of data, of statistical data, based on which we can make even some graphs presenting the test results. In science, also the data resulting from experiments. So in science, we have many experimental activities. And of course, when you do experiments, you can do measuring. And when you do measuring, you have collection of data. And then you need to analyze it, or to present it, or to draw conclusions or make estimations. In business, of course, current and past data is used to make the predictions. And I can give you a very simple practical example of a restaurant, for example, that has a menu, and it would be wise for the food and beverage manager to keep track of who orders what from the menu. So if after 6 months or after 12 months you see that something you have in the menu, nobody's ordering it, so then you make a decision, or very few people, you can make a decision to delete it from the, or remove it from your menu. Or maybe you can see that in the months of, or the summer months or winter months, people order certain foods more than other months, and then you can make a decision to have a summer, let's say, menu and a winter menu. So there are many things you can do as long as you keep and collect data for whatever you do. Some definition of basic terms. Of course, we have what we call the random sample. We use sample of a population in order to predict or make estimations for the population, because usually it's impossible, or it's too costly, or it's too lengthy in time to collect data from full populations. Let's say you want to do a study for the citizens of a whole city, like Limassol, for example, and then you want to investigate what the citizens do between, let's say, 7 and 8 o'clock in the morning. And one way to do is to ask all people who live in the city of Limassol, but as I mentioned, this may be too lengthy in time and too costly. So one can do take a sample of 500 citizens of 1,000 citizens in a random way, but also in a systematic way, or in a stratified way. What do we mean by this? Is that if the population is 55% women and 45% men, you want to make sure that your random sample has close percentage of women and men close to the known, to the population, because it's possible that your random sample end up with 80% men and 20% women. That would be a very bad sample. So sometimes we can control. There are methods to control certain parameters, like the gender and like the age as well. If I'm investigating the whole population has, let's say, adults from age 18 to 60, 70 plus. So you want to make sure you cover the all ages in your population. So you have to make sure in the sample you don't have replies only from people of age in their 20s, but you have the whole distribution of ages. So you can control this with so-called stratified sample to make sure your sample is representative in characteristics of the whole population. On the other hand, if I want to investigate the whole country, then the one city then becomes a sample. So for the city, I can have a sample taking some citizens from different regions of the city, controlling gender and controlling ages. That would be a sample for investigation of the city. But if I'm investigating the whole country, then the city itself could be a sample. Of course, it would be a bad sample, because in that case, if I want to get a national sample, then I have to take citizens from each city, and even from rural areas. But we will talk more about sampling techniques later on. Some other issues are the nomenclature is a word variable. We would be using mathematical notation to represent statistics and parameters, and of course these are variables. But sometimes we have the so-called continuous variables and discrete variables. Continuous meaning that These are numbers that can be that are really real numbers, meaning that they are continuous, like our weight could be, for example, a continuous number, since I can be 100, 100.1, 100.2, etc. Kind of continuous numbers. On the other hand, if we're talking about number of people, number of students, number of animals, etc., then these are discrete. You cannot have 5.5 or 5.1 students, for example. So when we are forced to use integers, these are called discrete variables. Then we have measurements or quantitative data. And of course, as I mentioned already, if we measuring weight, if we looking at the grades, because these are measurements and or scores, and usually this is called data. Of course, we have categorical, frequency, or qualitative data. So if we're talking about grades A, B, C, then this is more qualitative data, and or if we're talking about data sorting into groups with frequency, then it's categorical. So you can have the height in a categorical way also, from highest to smallest, etc. Then we have independent variables, of course, which are those that we are measuring, and then you have dependent variables which cannot be controlled. So the independent variables are changing the dependent variables. So let me go to the next set of notes. So we should know about measurement scales, nominal scales. Here we're labeling data such as male, female, Democrat, etc. For example, these are nominal data. Usually they are not numeric. And then we have the ordinal scales, which are data when it's placed in order. So we're ordering people heavier to lighter, we're ranking, etc., etc. In your book on pages 6 and 7, you can find more definitions about interval scale and ratio scale. So I suggest you read this before you see the next video lesson. Let's go to some other terms that we need to know and to use. When we talk about the sample, we already mentioned this is actually a subset of a population. You know what a subset is, we said. So if you see the population as a set, then a part of that is a subset, and this is what we mean by a sample. So we take a portion of the whole population, and we call it sample. And usually what we do, we use the sample to predict the behavior of the population. Variable, we already said that, the characteristic of interest about each individual element of the population. Let me give you an example. The student's age at entrance into school or into college, the color of his hair or her hair, his height, weight, etc. These are all variables, because for different students, that will be a different value, of course. So it's something that is changing. The word data, which can be used in both singular and plural, when we use it as a singular, the value of the variable associated with one element of a population, for example. So we're talking about the one single value when we take measurements. This is called data, but also if you take a set of values collected, let's say, from the variable, this is also called data. So then the word experiment, this is usually a planned activity whose results yields a set of data. So when you do an experiment, let's say, you can measure the rain falling every day and measure how much centimeters, how much millimeters of rainwater you collect every day, and you can do this throughout the school year, for example, as a project. And then this is kind of an experiment of collection data, And of course, then you can compare to previous years or the following years, you can find average rainfall, and you can make a plot, a graph, and present the data, of course. And this would be an example. A parameter is a numerical characteristic of the entire population. So if we talk about the average or the mean of a sample, then it's statistic. But if we talk about the average or the mean of the whole population, then it's called a parameter. And usually we use Greek letters to represent parameters, and we use the English alphabet letters to represent statistics. So if I can use this writing. So the statistic for X bar would be representing the mean, for example, but for population, it would be the letter mu. This is the Greek letter mu. So for parameters, the average would be symbolized by this letter, and for statistics would be symbolized by X bar, we call it. All right. Let me go to the next set of nodes. Oh, I have to remove with the eraser what I wrote. Okay, nice. All right, close this. Let me go to the next. Frequency distribution. This is the first attempt to begin to organize data. Let's say we have an example of 30 numbers, IQ scores of 30 high school students selected at random. And okay, an IQ score, if you never heard of it, is a score that indicates how smart someone is, or indicates it's a measure of ability or measure of competence. And it's a procedure like a test that you take in order to get this number. So if the highest number you have, the more competent you are. Usually people with more than 150 IQ are considered smart people. Okay. All right. Here we have 30, but by just looking at the data, of course, it's not clear to see how these 30 students are distributed. So in order to organize the data, usually we look to find what is the smallest number in our data. Here we see 89 as the smallest, and I think 140 something is the largest. I mean, we don't have a number more than 150. So we can organize this data. One way to organize it is to make these intervals 80 to 89, 90 to 99, and 100 to up to 140, 149. Now, why this and not 80 to 84, 85 to 89? It is possible to do 88 to 84, but that will have double number of intervals to cover the distribution. So usually I try not to have more than 10 intervals when I make a distribution. So you can take the smallest and the largest number, see the difference, and divide by 10, right? So if the smallest is 80 and the largest is 150, the difference is 70 points. If you divide by 10, it's about 7 points. But so if I want to have 7 scales, then it would be 70 divided by 7, it would be 10 points left each scale. So this is one way to do it. And then what do we do to create this frequency distribution? We start looking at the numbers horizontally or vertically, and whenever I see a number, let's say 100, then I know 100 belongs to this scale. I put a tally, just to make a mark that I have one number belonging to this scale. Then I go down to 90. So I have 190, it belongs to here. So I put a tally there. Then 105 belongs to this interval. I put another tally. And then whenever I have 4 and the next one 5, you know, I put a cross like this. So I indicate that I already have 5 numbers in this interval and so forth. So when I complete this marking with tallies, I count the tallies for each interval. So in 8089, I have 1. In 19 to 99, I have 3, then 7, then 5 and 4, 9, 5 and 2, 7, 2 and 1. And if you add these frequencies, these are called frequencies. It's the frequency of numbers falling within each interval. So if you add them up, you should find 30. If you find 29, that means you missed one. If you find 31, that means you counted one twice. So make sure the total number here of frequency agrees with the total number that you have. This is called a group frequency distribution. These are called class frequencies. Huh? These are called intervals of classes. And of course, these numbers are called class limits. And each, so we have lower class limits, huh? The left, and upper class limits, the right ones. Of course, these classes contain, as we said, 70 divided by 7, 10 points. So, but we only see 9 points, 90 to 99. Looks like it's 9 points, but actually, this class contains numbers or potential numbers between 89.5 and 99.5. And these are called the real class limits, the 0.5, 89.5 and 99.5, and also called boundaries, or sometimes true class limits. So in different books, different statisticians use different language sometimes, but they all mean the same thing. So this is an interval score. It would be nice to, when we see this, it would be nice to try a different set of scales. So as an exercise, you can try 80 to 84, 80, 85 to 89. Of course, 80 to 84, you will have 0. So it's possible to have 0 here. So in that case, maybe you start from 85 to 89 because the smallest number here is 89. So you can try that as an exercise. But let me go to the next. See more language, more statistical language. So we have the class mark. Class mark is usually the midpoint of a class. What do we mean by a midpoint? We take the two boundaries, the two 80 and 89, and we compute either the boundaries or these limits. 80 to 89 divided by 2, that gives you 84.5. So this is the called the class mark, huh? Or it's actually a potential one, but you can use this number to represent the class depending on what you want to do. So we might see this representation when we do graphics, for example, to represent the frequency distribution. Class interval, I think we already mentioned, is 10 because it's the difference between the boundaries, the lower and the upper. Then what you can do with your data, what else you can compute, or sometimes useful to know, is what we call the cumulative frequency, less than or greater than. The less than, of course, is the number of cases, as we say, of frequencies at and below a given point. So we usually, to do this, we use the upper limit of the corresponding class interval. So if we look at our previous, remember our previous distribution, we can ask the question, how many numbers are 89 or less, huh? Using the upper limit. And of course, we had only one. But if you ask the question, how many are 99 or less, of course, you have the frequency of 2 in this class plus 1 of the previous, because a 99 or less includes the previous class as well. So it would be, you have 3 in this one. So 3 plus 1 makes 4. Huh? So the cumulative frequency of 99 or less is 4. In the same way, when I ask how many numbers are 109 or less, in this class we had 7. So 7 plus the previous one, because we're talking everything less than 109 includes this 7, this 3, and this 1. That makes 11. In the same way, 119 or less, it includes the 9 of the current class plus the previous ones. 9 plus 7 plus 3 plus 1 makes 20. a practical way to find it. Of course, you can take this number 1 and then say 1 plus 3 gives you 4, and then 4 plus 7 gives you 11, 11 plus 9. You keep adding the previous one, 20, 20 plus 7, 27, 27 plus 2, 29, 29 plus 1 plus 7. Now, what you have to remember here is that the last number here should agree with the total number of scores you have. So this is another way of checking that you haven't missed one. And then, of course, we can make a cumulative frequency greater than. I think we can try to do this together on the piece of paper using the external camera. Let me see if I can manage. First of all, copy these numbers into a piece of paper, please. And I'm doing the same thing. So it will only take a few seconds. And 20 to 129 is 7, and 130 to 139 is 2, and 140 to 149 is 1. And we want to keep asking the question now of something greater than something. So we look at the lower limit. So we want 140 or more, right? So we have the frequency, and then we have the cumulative frequency more than. So let me switch cameras to show you. Okay, I think I have to stop the background. I have to remove the background. Okay. With the focus, it's good enough. Remove the blur. Okay. I think you can see now. Okay, there. Okay, then this portable camera is not very stable, but we will manage. Okay. Here you are. So we have our distribution, and we want to ask the question how many are 140 or more. It's only one, right? And then we ask the question 130 or more. That's 1 plus 2, right? Makes 3. Then 120 or more, that would be 7 from here plus 3 already makes 10. And then 110 or more, that would be 9 plus the 10, already 19. 100 or more, that would be 7 plus 19, 26. And then 90 or more, right? That would be 3 plus 26, 29. And then finally 80 or more will simply be 1 plus 29, 30. And again, remember that this cumulative frequency, the last one has to agree with the total number. So that would be a cumulative frequency more than the lower limit of each class. So this is another way of presenting data, depending on what you want to show. So let's go back to our camera. All right, we put our background. Okay. All right. And then we share again. Go back to our slides. Okay, so we still have time to continue with another way of presenting data. This is called the stem and leaf plots or displays. This is a method to retain some original information in our frequency distribution. And let's see what I mean by this. So remember that in the class 80 to 89, I had only one number. And so instead of saying one number, here we write the last digit, 89. In the next one, we had three numbers, but it was 90, 92, and 97. So by writing the last digit, I know or immediately, or I can see, or I can remember that these three numbers that I had in this class were actually the 90, 92, and 97. In the next one, if I do the same, it would be 100, 100, 100, 100, 300, 500, 507. So in this way, one looking at this distribution now knows exactly what are those 30 numbers. Huh? And here the region is called stem and leaf is because the line, each line is like a stem of a tree. And of course, each digit is like a leaf of the tree, and that's why it's called stem and leaf. Of course, you can try different practice here. Here we have to simplify a little bit. Sometimes you can see 8 star, 9 star, 10 star. So instead of writing the full class, you can even represent it with 8 star. Sometimes you can use even the midpoint, remember, of the class represented. But this is another way of presenting stuff, presenting data. So let's go to the next just to talk about what we do in the next lesson. In the next one, we will take this data and put it into graphs, the histogram and the frequency polygon, etc. So this is just the first slide of the next lesson, just to prepare you. But before before you go to the next lesson, make sure you do the exercises we mentioned and practice a little bit. So now I think it's time to show you what I promised this video. All right, let me share with sound. And let me close this. And enjoy this little video, which is taken from the internet, but I thought to share it with you. I didn't make the video, but it's something that it says Introduction to Statistics. You can find many such videos on the internet yourself. You already know how to use the internet and the Google search, and you can find many such videos to watch. But this is, I think, about 4 or 5 minutes, so enjoy it because it's a nice video. I like it.
What is statistics? Statistics can be defined as the collection and interpretation of data. All around the world, we use statistics to measure and analyze variability. People have different heights, weights, hair color, food preferences, and so on. These things are all variable because they change among different individuals. There are two kinds of statistics. There is inferential statistics and there is descriptive statistics. Inferential statistics deals with taking a sample and analyzing that sample to make judgments or claims about a population. Descriptive statistics refers to getting data and talking about it. So when you hear a professor say something like, the average midterm score was 65%, they are using descriptive statistics. We often use things like histograms and graphs to help us summarize and explain descriptive statistics. The first part of the course deals with descriptive statistics, and the second part of the course deals with inferential statistics. In order to understand statistics, you'll first have to know some basic definitions. A population refers to the total amount of things. I say things because a population can refer to almost anything. This can refer to the total amount of people, cats, vehicles, houses, and so on. Now, a sample refers to a small part of the population that is used for study, and the total amount of things in a sample is called the sample size. In statistics, what we examine is a variable. It is what we are studying, and it can be measurable, countable, and categorized. When we talked about how people can have different heights, weights, and hair color, these are all variables. Variables represent a characteristic of what we are trying to study, and they can vary among different individuals. When we measure a variable, our data can come into two different forms. There is categorical data and there is quantitative data. Quantitative data refers to data that is measured in numbers. It deals with numbers that make sense to perform arithmetic calculations with, like calculating an average. Quantitative data comes from quantitative variables. Examples include height, weight, and midterm score. On the other hand, categorical data refers to values that place things into different groups or categories. Categorical data comes from categorical variables. Examples include hair color, type of cat, and letter grade. There are actually two types of categorical variables. There is categorical and ordinal, and categorical and nominal. Something is said to be categorical and ordinal if there is a logical ordering to the values of a categorical variable. A good example of this would be letter grade. We can logically order the values of this categorical variable from high to low, or from low to high. Now, something is said to be categorical and nominal if there is no logical ordering to the values of a categorical variable. An example of this would be hair color. Depending on our sample, we could have people with red hair, blonde hair, brown hair, or even blue hair. Although we can arrange these values in alphabetical order, there is no logical ordering with respect to the actual values itself. There are also two types of quantitative variables. There is discrete and continuous. Discrete variables refer to variables that can only be measured in certain numbers. An example of this is the number of pets you own. You can own 0 pets, 1 pet, 2 pets, or even 30 pets, but it's impossible for us to own 2.7 pets. In contrast, continuous variables refer to variables that can take on any numerical value. An example of this would be weight. Someone can weigh 105 pounds, 185 pounds, or even 170.683 pounds. We can measure this variable in as many decimal places as we want, which is why it is classified as a continuous variable. So to recap, a population refers to the total number of things. A sample refers to a small part of the population that we examine and extract information from. The total number of things in a sample is called a sample size. What we measure from each individual is the variable of interest. The way we measure these variables lets us know if the variable is quantitative or categorical. For example, if our variable of interest was midterm scores for statistics, we would have quantitative data if we measure each individual's test score. If instead we decide to place people into categories based on letter grade, then we would be working with categorical data.
Okay, I think we are near the end of our lesson for today. So please go back and watch the video again if you wish. Do some practice, do some exercises as we suggest. And when you're ready, you can watch the next video, the next lesson. So have fun with numbers. Bye-bye.